Alright, here's a very important concept. It says if A times B is a 0, one of two things is going on. Either A is a 0, or B is a 0, right? The only way I can multiply two numbers together and end up with a 0 is if one of them is actually a 0. So this A has to be a 0, or this B has to be a 0. Okay? And it turns out that either one could be a 0, and it could be a true statement. So if we have two factors, say x plus 2 times 3x minus 4 equaling 0. Nice shot of my exercise bike there. Okay, then that means that this term right here is my A term, and this term is my B term. Okay? And if A times B is 0, then A's got to be 0, or B's got to be 0. Okay? So they both could be 0 here. So what we're going to do is we're going to say, alright, what if A is a 0? So what is A? A is x plus 2. So what if A is a 0? So B equal to 0. So let's solve for x. Subtract 2, subtract 2. X equals negative 2. Okay? So if x equals a negative 2, this whole thing is a 0. Now we can check that answer. Put a negative 2 in for x here, and a negative 2 in for x here. So negative 2 times 3 is going to be negative 6 minus 10. 4 is negative 10. Negative 2 plus 2 is a 0. 0 times negative 10, 0. Okay? So it works. But it's also possible that our B is a 0. I mean 3x minus 4 equals a 0. So solve for x. Add 4. 3x equals 4. Divide by 3. Divide by 3. And x equals 4/3. Okay? Oops. So if x is a 4/3, this whole thing is a 0. Again, I can test it. Put a 4/3 in here plus 2. Well, that's not 0. 4/3 in here for x times 3. It'll leave me at 4. 4 minus 4 is 0. Okay? So it works. Now, if this thing here were set equal to a 5, I couldn't use this method anymore. Okay? What I would have to do then is I would have to FOIL this out, then subtract 5 from both sides, and then refactor it. Okay? Which that gets kind of messy, but sometimes that's the way life is.